First of all, now we have this, which is pretty great, right? We just now have a wheel module that's spin, right? Which is very good, very cool, very nice. But now we want to build a robot, right? Well, that's only a very small step. Now you're going to have to mirror this entire operation over here. You're going to have to build a chassis. You're going to have to put two more wheels. You're going to have to put all your stuff. And that's really complex. That's really hard to think about, right? Especially if you're just starting off CAD without much building experience. Now, if you have building experience, you can just go like, well, I know what I need to do next. I need to put another wheel on, and I need to think about how this year's game is achieved. So, back in Ultimate Goal, the game was, I'll give you some context, right? The game was shooting these orange rings into these goals, these three-tiered goals. So, it was a small goal, medium goal, tall goal. And on the side of these goals, there was a little chute for that's CHUT for you to drop for the human player to drop rings into. That those go into the field. Okay, so you have to build a robot that grabs rings and shoots them into these goals. Okay, so a lot of teams tended to use the uh, same idea of intaking from behind the robot and outtaking from the front of the robot. Okay, now this was kind of flawed because the rings were, if your robot was facing forward, the goal was also forward. So your rings weren't going behind your robot, they were going in front of your robot. So what we tried to do was think up a plan. Okay, here's what we want from our robot. We want a robot to fit within 18 by 18 inches. We wanted our robot to be within 44 pounds. We wanted our robot to intake and outtake from the same direction, and we wanted our robot to strafe. So 2 out of 3 of those things are very easy to accomplish. Strafing is very easy to accomplish by just using mechanism wheels, and being within 18 inches is very easy to accomplish in the beginning. In the beginning, that's very important to stress, right? Now, what we did after that was like, well, how do we accomplish the other two problems, right? Or the other problem? How do we make it where we intake and outtake from the same direction? Now, the way that we thought about this problem is, well, you could just use a conveyor belt. Like, you can just make a giant like conveyor belt that just scoops them through. And I was like, how do you do that? Like, design it, show me. But the best we got was a drawing. And then I was like, wait, why not just make like a little tower like this, like a little pyramid, and it goes up and drops. So that's what we did, and it worked really well, right? But the hard part was going, how do I turn this into CAD, right? Because of course CAD is extremely useful in building a robot. Sorry about that. Regardless, I had to work on it and think about all the different ways we could do this. So going to this season, our question was we changed our parameters many times, which is part of the reason why we failed. But we changed our parameters many times. We went from we want a linear slide that goes up and down to we want a transfer that way we don't need to spin our robot every single time like a lot of other teams did, right? And then we were like, wait, but what if we just increase the intake arm so that we could just go to any like corner and just be like, oh hey, give me, and then pull back, and then transfer. And that's what we ended up with, right? We didn't have enough time to program, which is why our robot was pretty bad. But we essentially had this system here where oh, that's gonna crash my computer. Let's see what happens. But we tried to conquer the issue. How do we make an expanding intake without using belt or string? Because we had a bunch of problems with belt and string. Um, So we're like, okay, well, I'm going to make a linkage because we saw that other teams were using linkage. We knew 12791. I think that's their team number. Iterative Intentions were using a linkage. We knew another team from the NorCal area were using a linkage, and we're like, we are inspired to use a linkage. Let's do it. And I was responsible for catting this robot, and I was like, well, what the heck do I do? So one important thing to realize is ideation. How do you solve these problems? And the only way to do it is step by step, right? So first thing I thought of was, well, I know I have to make a linkage, right? So I'll actually show you all of the iterations that I went through to get to this design. So if you go into assembly, one important thing is to look at your design history if you want to look at all the things you did. First things first, we needed slides, right? So as this opens up, I'll let you know what we did. Open recovery file. Huh? Okay, let's save this. That's not right. One sec. Let me save this just to make sure it works out correctly. So you can go back and open, or you can create a milestone for when things happen. You can, and that's good for documentation, by the way. That's very good for, oh hey, my doc guy is like, oh crap, what'd you do? When'd you do it? Why'd you do it? Well, hey, I could just show you these milestones. Exactly. Yeah, exactly. So we tried using belted. We tried using belted horizontal slides and they didn't work. We tried using stringed horizontal slides. They didn't work. And we're like, okay, I'm tired of this. So I was like, okay, let me just design a linkage. By the way, the best part of CAD is that if you have a solution and you can design it, then that solution is probably what you're going to do. Because your team needs to know what exactly they're looking at, and that's why CAD is essential. If that makes sense, right? So no, wait, I want to. Sorry, just messing around. Okay, so this was one of my older versions. So first things first, I was like, okay, first I need to make a base. So I made a base out of these three channels. This channel here, which is this one. This channel here, which is this one. And this channel here, which is this one. And I connected all of them with quad blocks. And then I was like, okay, well, that's easy. And then I was like, wait, so where am I going to put my wheels? So I knew I could direct drive these two wheels because the motors were concealed, but I knew I had to make a bearing drive here. So what did I do? I just made a bearing drive, and it's easy for me to say I just made a bearing drive. So you have to know how things work first. For example, I know that I can only attach a motor in space with a quad block. But I also know that I can only attach a bearing to another bearing if the second bearing is on an axle. Well, I know I can only attach an axle if I have another constraining feature, which is my sonic hub. And I know that in order to have all of this stuff, I need bearings here and here. Right? This other bearing's hidden, but you'll see it. You can be able to see it on the real robot. So I took all those things and I was like, okay, how am I going to put it together? Well, this goes onto here, which goes onto here, which goes onto here. All the axle things line up. It would actually. So this was a huge problem with our thing, but all we needed to do was change how fast this wheel was driving, and it wasn't necessarily gear ratios because these are 1-to-1. These gears, it was more friction. So we had to play with the looseness and tightness of these bevel gears to work with that. So what I would recommend for any newbies, do not make a drive system that uses either bevels or direct drives, make a drive system that uses like that doesn't combine them is what I'm trying to say. So don't have bevels and direct. Just do direct or just do bevels. Okay, that's my biggest recommendation. Now, anyway, back to it. So I figured out what I wanted to do with my chassis, and then I was like, how am I gonna conceal huge slides? These two SAR 230s. And then I was like, wait, they fit inside. I can stack 3 stages inside of a U channel. So that's what I did. I made 2 U channels, attached them, put the slides inside of them, figured out how to attach those slides, and that was it, right? And I made special inserts for the slides. Now everything's locked here, so I can show you on the outside edge, I think. Wait, is that not a component? Well, that's silly of me. Anyway, you can go like this and you'll be able to see how these slides work, right? They extend in and out like that. And then I was like, well, where am I going to put the linkage? So I said, well, the linkage is just going to be attached to the front. And then I was like, okay, well, I wanted a turret. Where am I going to put the turret? I'm just going to use an axon servo and put the turret right in the center of the robot. But I was like, where am I going to put the turret though? So I put a U channel between these 2 channels that were already here. I was like, okay, well, that's how I'm going to put the turret on. And then I was like, well, what next? I have to put the slides on. So I went back and made slides. Oh, because the front 2 are different. Yeah, but like, it worked, so I don't know. I think it was a programming thing at the end of the day. Because if the gear ratios are different, couldn't you just drive one set of motors more than the other? Like, or less than the other? If you're doing this, if you have a speed mechanical advantage? Regardless, that doesn't matter. So, we had to solve problem by problem. Well, not problem by problem, but like, the best ideation is to ask yourself, well, how am I going to do this? How am I going to do that? How am I going to do this? Knowing the ways that you can do it. Okay? So at some point, I was like, well, now I have to insert my slides. We had a really big thing that we need to do. We were questioning how am I going to make slides that are belted? Because we wanted Misumi slides, right? Because Misumi slides, not heavy, not not slow. So we were like, well, what are we gonna do? And then I looked at the Viper slide video on how they make the Viper slides, and I was like, well, I can just copy this. I can just use how they do the Viper slide belted, and make it into a Go Build a system. And that's exactly what I did. So if you look at, I'll have to find it first. There we go. I think this is it. Yep. So first, I took the long robotics inserts from Misumi and changed them so that they would fit the larger diameter of the idler, or larger length of the idler bearings. Because of course string is so much less thick than belt, but belt is better. I mean, belt is better. I don't care. Belt is better. I will never not say belt is better. But so now I was like, well, now what? In the Go Build a Viper slide video, you have a string system, or the belt system that goes up and under, and then over, under like this, right? And I needed a way to attach this back plate to the Viper slide, or to the Go Build a C channel. So that's what I did. I made a back plate, and then that elevates off the C channel base, and then you thread the belts through, and then you have a place for one side of the belt, and then a place for the other side of the belt, which is here and here. And then I was like, well, I need to be able to put my outtake on. So I made 2 holes here, one for the top outtake, one for the bottom. Or one for the top one for the bottom. And that's how we made it. One of the most solid, like, linear actuation systems that I've ever seen. Like, this system was so nice. It like never failed. The only time it failed was putting too much stress on the belt and snapping. But that was a very easy fix because we already had slack in the system and we just needed to reduce that slack and that's it, right? So I would highly recommend you go with belt. But that was a huge problem we needed to solve. Hey, how do we belt Misumi slides? So we took the resources that were already there and altered them to fit our purposes. That's all CAD is.